Here in problem 2, we want to find the area bounded by this function right here, 1 over x squared, above the x-axis and between x equals 1 and x equals 2. Now, we're not asked to do this here, but I'm going to put a graph in here just so we get a good feel of what it is that we're looking at. So I've dropped a graph in here that I got on a free program called Desmos, D-E-S-M-O-S. A very nice graphing program, and I've graphed our function, 1 over x squared, and I've got a little bit more than our interval. I went from -1 all the way out to about 5 or 6. So anyway, what we want to do is we want to get the area under this curve, above the x-axis, and bounded by these lines, 1 and 2. All right, so here's x equals 1. Now, look at this is 0. That would be 1, 2, 3. All right, so I want the line x equals 1. That's going to be here. And x equals 2. That's going to be here. And we want this area right here, right? I want the area bounded by the curve between the lines x equals 1 and 2 and above the x-axis. So we're going to get this area using the definite integral from 1 to 2 of f of x, which is 1 over x squared dx. So this is going to give us, how about 1 to 2 of x to the -2 dx. This will give us, all right, x to the increased by 1, -1, divide by that new exponent from 1 to 2. Now, I'm going to take the negative up and the x down. So this is going to be -1 over x from 1 to 2. This is, all right, put in the upper limit. We'll get -1 over 2 minus, put in the lower limit, -1 over 1. I'll do it up here at the top. So we'll get -1/2 plus 1, which is exactly 1/2. So what we're saying then is that this area right here under that curve is 1/2 of a square unit.